NASA is looking forward with anticipation to a new era of human spaceflight. This new era will have a profound impact on your life, with countless possibilities in the coming years. After the Apollo program, which took Americans to the moon, the Space Shuttle program gave us 30 years of outstanding achievement in space. The shuttle enabled the space program to conduct space research, fly science observatories, launch satellites, and assemble the International Space Station. The station, a partnership among 5 agencies representing 15 nations, has been continuously crewed since November 2000, enabling astronauts to gain valuable insight on how to live and work in space 365 days a year. In collaboration with engineers and scientists on Earth, astronauts have collected and stored solar energy, recycled wastewater to minimize water needs from Earth, conserved water usage, created the air they breathe by splitting water molecules with electricity, grown plants without gravity, and kept their bodies healthy in zero gravity. Research on board the space station has provided advances in biology and biotechnology, physics, material sciences, robotics, and many other disciplines. The station has lifted us high above political, cultural, language, and national boundaries to observe hurricanes, tsunamis, forest fires, and volcanic action from afar while circling the world every 90 minutes. Through at least 2024, the space station will have rotating 6-member crews to advance research and technology in low Earth orbit, roughly 220 miles above the Earth. To replace the space shuttle, which is no longer delivering cargo and crew to the space station, NASA is entering an extraordinary new era. NASA is investing financial and technical resources to stimulate efforts within the private sector to develop and demonstrate safe, reliable, and cost-effective cargo and crew space transportation capabilities. Innovative spacecrafts and launch vehicles are changing the way cargo, and will change the way crews, are transported to the International Space Station and to low Earth orbit. Further, this is creating a market environment in which space transportation services are also available to private sector companies. Having opened low Earth transportation to U.S. industry, NASA is focusing on developing 2 necessary elements for future human deep space exploration: a crew vehicle called Orion Multipurpose Crew Vehicle, and a heavy lift rocket known as the Space Launch System, or SLS. The programs for these vehicles are moving out, intensely focused on meeting the goal of flying the new rocket and Orion without crew by 2017, with the first crew flight to take place in 2021. Using the lessons learned from over 50 years of spaceflight, NASA is testing and building an advanced space exploration system that will take our astronauts to deep space destinations humans have never visited and return them safely to Earth. The Orion will be outfitted for long-duration missions that reach far beyond low Earth orbit. For this reason, the spacecraft will incorporate innovations and advancements in the crew escape system, electrical power system, rocket engines, navigation and flight control systems, and communications systems. Orion will also require radiation protection for the crew and safe, reliable life support systems. This new spacecraft will be launched on the SLS rocket, which will send astronaut explorers on more challenging and distant missions. The rocket will be the most capable U.S. launch vehicle built to date, and with the Orion, will enable human exploration into the solar system. To journey into deep space, NASA is pursuing an integrated space exploration strategy that supports both science and human spaceflight goals and advances space exploration technology. Mission analysis and international discussions supporting this strategy are ongoing. NASA will ramp up our capabilities to reach and operate at a series of increasingly demanding destinations while advancing our technological capabilities with each step forward. This will include early test and demonstration flights between the Earth and Moon, with NASA planning to redirect a small asteroid to a distant retrograde lunar orbit and send humans to explore it, then possibly visit one of Mars' moons, Phobos or Deimos, or the surface of the red planet itself. By visiting a captured asteroid in lunar orbit, astronauts will learn how to do long-term space operations in a deep space environment while maintaining close proximity to Earth, and gain vital information exploring territory untouched by humans since the formation of the solar system. An asteroid mission requires new space transportation vehicles and systems that are capable of operating in an environment with almost no gravitational field. NASA is conceptualizing habitat and spacewalking systems with new spacesuit designs and anchoring tools, and robots that can work side by side with the crew or be remotely controlled. Traveling to Mars is our ultimate goal. Why Mars? Like Earth, Mars has an atmosphere, water, ice, and evolving geology. Robotic rovers that NASA has sent to Mars are investigating whether the planet has ever been capable of supporting life. Because of its Earth-like attributes, Mars is seen as an excellent candidate for human exploration as we expand into the solar system. It could take up to 6 months to reach Mars. Then, because of flight trajectories, astronauts will have to leave within 30 days or remain on Mars for 500 days. On the way to Mars, the crew will have to cope with different kinds of stress in a high-risk, confined environment with limited communication with Earth. As NASA travels through the solar system, astronauts will need to communicate quickly with other spacecraft and Earth, and in emergencies, even hold video conferences. For this, NASA is developing a communication system to operate at higher radio frequencies and at optical frequencies using laser communication systems. A new internet system is being developed that will give each planet its own domain name. For example, www.alphabase.mars. The new system will even compensate for the great time delay in communicating between bodies in space, which is 29 minutes one way when Mars is closest to the Earth. The long voyage through deep space is filled with many dangers, including protons from solar flares, gamma rays from distant newborn black holes, and galactic cosmic rays from outside our solar system. Astronauts have not experienced complete exposure to deep space cosmic rays since the Apollo missions, which were of short duration. When astronauts are on the International Space Station, Earth intercepts about 1/3 of cosmic rays, and 1/3 are deflected by Earth's magnetic field. So, before sending humans into deep space, we need to research and develop new technologies and materials to protect astronauts. There are other health hazards to research before attempting long voyages as well. NASA has been continually investigating protective solutions for physiological changes that occur in heart function, bone mineral density, muscle mass, sensory motor skills, and the immune system. On the space station, we found that aerobic and resistive daily exercise protects the astronauts' bones, muscles, and heart very well. So exercise equipment will be necessary on longer exploratory missions. Additional challenges will arise with having small groups of people in an isolated environment for long periods of time, with prolonged interactions between humans and machines, and with maintenance of sufficient quantities of food with adequate nutrition. NASA is working to identify solutions for all of these challenges on future missions. Once on Mars, astronauts will find evidence of extensive water erosion, channels, and floodplains. Astronauts will extract subsurface water for their use. The crew will need surface systems to produce air to breathe, fuel for vehicles, and equipment to mine and process resources. But then, these astronauts will have the distinction of bringing Martian samples back to Earth, which will transform our understanding of Mars. As always, new technologies developed to overcome the challenges of interplanetary travel will also find applications that improve life on Earth. Thousands of technological spin-offs have benefited American industry and citizens in the decades since NASA's 1958 inception, while NASA's cost to the American taxpayer is currently less than 1/2 cent of each federal tax dollar. So today, NASA looks forward to writing the next chapter of human spaceflight with its commercial and international partners, advancing research and technology on the International Space Station, opening low Earth orbit to U.S. industry, and pushing the frontiers of deep space even farther. As NASA's next chapter in human spaceflight evolves, there are new and increasing opportunities for each citizen to experience low Earth orbit, to become involved in new facets of an expanding space economy, and to view new vistas in deep space virtually through NASA's exploration. As Space Shuttle Atlantis launched on the last mission of the shuttle program, astronaut Commander Chris Ferguson said, "We're not ending the journey today. We're completing a chapter of a journey that will never end." Please join us for the next exciting chapter of NASA's journey.